Welcome to the Deep Dive. Today we're tackling, well, a really crucial topic. It's been making waves, especially, I think, for those of you following daily UPSC current affairs.
hmm
We're talking natural hydrogen. You might have heard it called white hydrogen or maybe gold hydrogen.
That's right. And its potential as really a game changer for India's clean energy goals, aiming for net zero by 2070.
Exactly. And you, our listener, especially if you're gearing up for mains or prelims, you want the insights, fast and thorough.
Yeah.
So this deep dive, and we're drawing heavily from a great piece in the Hindu, this is basically your shortcut to getting up to speed on this emerging area.
Absolutely. Our mission today really is to unpack what the Hindu reported about India's natural hydrogen potential. We want to give you a clear view of the latest estimates, what they mean for energy strategy.
And why it's popping up more on the UPSC syllabus, right? Science, environment, economic policy, it ticks a lot of boxes.
It really does.
Okay, so let's just jump right in with a big number. The Hindu mentions studies suggesting India might be sitting on, wait for it, 3,475 million tons of natural hydrogen.
It's a staggering figure, potentially. And you have to see it in context.
Okay, let's do that. Context for UPSC prep. India's hydrogen need is already substantial and it's set to grow massively.
That's the key point from the Hindu piece. India's current annual demand, around 6 million tons back in 2020, is projected to explode. We're talking over 50 million tons a year by 2070.
Wow.
And that jump is directly tied to hitting those net zero targets. It's a core part of the environmental strategy you need to understand.
So that huge potential reserve figure, 3,475 million tons, suddenly looks incredibly important, doesn't it?
It really does, because if those estimates hold up even partially, and if we can actually get to it,
Right. Accessibility is key.
then we could be looking at a fundamental shift. It could dramatically cut down our need for hydrogen made using other methods that are often really energy intensive.
Which kind of defeats the purpose sometimes if you're using fossil fuels to make clean hydrogen.
Precisely. That's the issue. Natural hydrogen, if we can tap into it directly, could offer a much cleaner, more efficient route.
The Hindu article also mentioned some early, quite exciting signs, didn't it? Like potential discoveries underground in the Andaman Islands.
Yes, and in similar geological settings elsewhere in India, it definitely sparks the imagination.
Feels like we could be onto something big here.
It certainly feels that way. And for UPSC aspirants, notice the geography Andamans, other potential zones across the country. But, and this is crucial,
Yeah.
the Hindu rightly stresses these are preliminary findings. They're theoretical possibilities right now.
Okay, so needs validation. Lots of it.
Exactly. Rigorous geological surveys are needed before we can confirm anything. It's promising, yes, but still early days for science and policy.
So to actually tap into this, assuming it's there, what comes next? Sounds like we need a much, much better map of what's under our feet.
You've hit the nail on the head. Unlocking natural hydrogen is fundamentally about understanding India's incredibly varied geophysical landscape.
Okay.
And the Hindu highlights some promising areas based on their geology. Knowing these is pretty valuable for your geography and sci-tech papers.
Like the Darwar and Singphum cratons, these are really old parts of the Earth's crust, right?
Oh, yeah.
What makes them interesting for hydrogen?
What's key there is the potential for hydrogen-generating rocks. These ancient, stable cratons often contain specific iron-rich rocks.
Okay.
And deep underground, when water interacts with these rocks, a process called serpentinization.
Serpentinization, got it.
Hydrogen gas can be produced as a byproduct. Understanding these geological processes is definitely prelims-worthy material.
But producing it is one thing, trapping it is another. That's where the Vindhyan and Gondwana basins come in. The Hindu mentions adequate seals and traps.
Correct. You need both the source rock generating the hydrogen and then geological structures that stop it from just leaking away to the surface.
It's like a lid on a pot.
Sort of, yeah. These basins often have layers of impermeable rock shale, salt that can act as seals, and folded or faulted structures underneath can create traps where the gas accumulates. Understanding resource geology basics is vital here.
And then there are the ophiolite complexes mentioned, Himalayas, Andamans again. What's their deal?
These are geologically quite different. Ophiolites are basically slices of ancient oceanic crust and upper mantle pushed onto continental crust.
Wow, okay.
They often contain those iron-rich rocks prone to serpentinization, and the intense tectonic activity associated with them can create complex fracture networks, potential pathways, and reservoirs for hydrogen.
It sounds like a huge jigsaw puzzle. Putting it all together nationally, well, that seems like a massive undertaking. The Hindu compared it to efforts in Australia and the US, like OSLAMP and USARE.
Yeah, and those comparisons are important. National level initiatives like those are crucial because they provide a comprehensive 3D picture of the
It's a
subsurface.
3D picture.
Using techniques like magnetotellurics, they build these large-scale 3D resistivity models. Basically, they map how easily electrical currents flow through the rock deep down.
And different rocks conduct electricity differently.
Exactly. And the presence of fluids, like water or potentially hydrogen, also changes conductivity. So these models help pinpoint promising geological zones without having to drill everywhere first. It's like an MRI for the Earth's crust, essentially.
Smart. But it's not just one technique, is it? The article mentioned needing public-private partnerships, magnetotellurics, petrophysical surveys. Sounds pretty high-tech.
It definitely involves advanced geophysics good to track for science and tech updates for UPSC. Magnetotellurics uses natural electromagnetic fields to probe deep structures.
Okay.
Petrophysical surveys analyze rock properties, often from core samples from existing wells, to see if they can generate or hold hydrogen.
And the public-private partnerships.
Essential for something this big and technically demanding. You need government coordination and funding, plus private sector tech and operational expertise.
Okay, so let's say we get better at finding potential spots. Actually, exploring for natural hydrogen isn't like looking for oil and gas, is it? The Hindu mentions specific hurdles.
No, it's quite different. And this is a key point for understanding resource extraction tech. Detection is a major challenge.
How so?
Unlike oil and gas, we don't really have well-established, reliable methods to directly sense hydrogen underground from the surface. It's colorless, odorless.
Doesn't show up on seismic surveys the same way?
Exactly. It lacks those clear geophysical signatures we often rely on.
And then, even if you find it, getting it out sounds tough because hydrogen molecules are just so tiny.
That's the other big challenge. Hydrogen's tiny size and high diffusivity mean it wants to escape. It can seep through rock pores and fractures that would hold back larger methane molecules.
So standard oil and gas extraction tech might not work well.
Probably not directly. We'll need specialized technologies, maybe new well designs, techniques to manage how the gas flows through the rock, ways to prevent leaks. It's an active area of research.
And safety must be a huge factor too. Hydrogen is known for being quite reactive.
Absolutely critical. The Hindu rightfully flags the significant safety risks. Its flammability range is wide. It burns with an invisible flames. So rigorous safety protocols are non-negotiable. From drilling to transport. This means innovation in materials like hydrogen-resistant coatings for pipes, better cement for wells, upgraded seals.
It's good to hear there's ongoing research, though, especially on maybe using existing gas pipelines. That sounds like a potential cost saver.
It's a very important consideration economically. Retrofitting some existing natural gas pipelines could offer a faster, cheaper way to build out some initial transport infrastructure.
But not without changes, I guess.
Definitely needs modifications. Hydrogen can make steel brittle over time, and its small size means leaks are a bigger concern. So upgrades and careful monitoring would be essential.
Interesting. And looking internationally, the Hindu pointed out the U.S., specifically ARPAE, is being really proactive, going beyond just finding natural deposits.
Yes, and that's worth noting for future tech trends. ARPE isn't just looking for naturally occurring hydrogen. They're funding research into inducing hydrogen generation.
Inducing it? How?
By, for example, injecting water into specific iron-rich rock formations to deliberately trigger that serpentinization process we talked about.
So creating hydrogen factories underground, almost.
In a sense, yes. It could potentially create hydrogen resources where they don't exist naturally in large amounts.
And they're also looking at combining it with carbon capture. That sounds almost too good to be true. Make clean energy and store CO2.
It's a fascinating synergy. Some hydrogen-generating processes might also involve CO2. If you can develop ways to capture that CO2 geologically while extracting the hydrogen, it's a double win for the climate.
Wow. And this idea of intentional geological hydrogen reactors.
That's really pushing the envelope. Thinking about engineering-controlled underground environments specifically designed for optimized hydrogen production. Very futuristic, but actively being explored.
So how does India learn from this? We have an existing oil and gas sector, right? The Hindu suggested leveraging that.
That's a smart approach. India can definitely tap into the expertise and infrastructure of its existing exploration network, especially under the Directorate General of Hydrocarbons, DGH.
They have the geological data, the drilling know-how.
Exactly. And a relatively low-cost first step, as the article notes, is simply re-examining rock cores already collected from thousands of previously drilled oil and gas wells. They might hold clues about hydrogen potential we overlooked before.
Makes total sense. Go back through the archives. And the pipeline repurposing idea, again, a potential shortcut.
It offers a significant potential advantage, yes. Reduces some initial infrastructure hurdles. But again, always with the caveat that modifications and safety upgrades are paramount.
Okay, let's talk brass tacks, commercialization. The Hindu mentioned that even if long-term costs are low, getting started is expensive.
That's the reality for any new energy technology. Exploration is costly, developing new extraction tech takes investment, building infrastructure is a major expense. Right.
So while natural hydrogen could be cheaper down the line, those big upfront investments need addressing.
So what does the Hindus say are the key ingredients needed to make it commercially viable here in India?
Several critical factors need to line up. First, obviously, you need to find large enough reserves that are relatively easy to access. Scale matters.
No point if it's just tiny pockets everywhere.
Precisely. Second, you need those low-cost extraction technologies we talked about. Efficiency is key. Third, investors need clear rules. A transparent, supportive regulatory framework.
Reduces risk, encourages investment.
Exactly. And finally, targeted government support grants, incentives, maybe risk-sharing mechanisms, especially in the early exploration and pilot stages, can really help get things moving.
The article made a really interesting comparison to India's national solar mission. How could that experience help with hydrogen?
The solar mission was incredibly successful, wasn't it? It set a clear vision, ambitious targets, spurred R&D, brought down costs, and fostered public-private collaboration.
Yeah, it really transformed the solar landscape. So, the Hindu suggests a similar approach might work here. Maybe a dedicated natural hydrogen mapping mission.
A focused national push.
Right. Something to coordinate the exploration, build expertise, maybe fund pilot projects, raise awareness, act as a catalyst, just like the solar mission did.
Okay, so summing up, it feels like natural hydrogen genuinely holds massive promise for India. Clean, homegrown energy sounds great.
It really does. The potential strategic and economic benefits are huge, as the Hindu concludes. It could be a really transformative element in India's energy story.
But getting there isn't guaranteed.
Not at all. As we've discussed, realizing this potential hinges on a lot of things falling into place.
Coordinated efforts, right? Scientific exploration needs to ramp up.
Technology for extraction and safety needs serious development.
And government policy needs to be clear, supportive, and forward-looking.
It's a complex equation, definitely. But the payoff, in terms of energy security and meeting climate goals, could be immense for India.
Okay, so final thought for you, our listener, especially with your UPSC prep in mind. We've laid out the huge potential, but also the significant hurdles. How do you think developing India's natural hydrogen resources might actually reshape the country's energy policy? And what about its position on the world stage, its geopolitics?
Yeah, and what are those tricky trade-offs? The environmental considerations versus the economic ones?
Right.
Policymakers will have some tough calls to make as this evolves.
These are exactly the kinds of analytical questions that link science, policy, and economics perfect for your UPSC thinking.
Absolutely. Understanding these emerging energy frontiers is becoming crucial.
So what are your thoughts on all this? We really want to know. If you found this deep dive useful for your prep, do hit like and subscribe.
And please drop a comment below. Any further questions you have about natural hydrogen, let us know. We're always keen to explore what you're curious about.
And remember, our discussion today drew significantly from reporting in the Hindu. Worth checking out the original piece, too. Thanks for diving deep with us today. We'll catch you on the next one.